We all have experienced those frightening nights when suddenly our sleep gets interrupted by the strong noise of thunder. And then we look outside to see the lightning covering the entire night sky. Even though lightning looks scary, it's one of the beautiful phenomena that occurs naturally. Have you ever wondered how lightning happens in the sky? It's not just a flash of light, but a powerful natural phenomenon that shows the incredible energy between the earth and the clouds. Today, we will learn how lightning forms and some amazing facts about it. So let's begin. In order to understand how lightning occurs, we need to know what lies inside clouds. We often think of clouds as being nothing more than fluffy white masses floating lazily in the sky. However, this couldn't be further from the truth. Beneath their soft appearance, clouds are bustling with activity. Inside rain clouds, tiny water droplets and ice particles collide with each other at high speeds due to wind currents. These collisions generate static electric charges which accumulate in the clouds. As the charges build up, they form massive electric fields. These fields are primarily composed of positively charged protons and negatively charged electrons. Usually, the bottom of the cloud becomes positively charged and the top part of the cloud, or the part closer to the Earth's surface, becomes negatively charged. Sometimes the opposite can happen. The reason for this separation of charges is still not fully understood, but scientists believe that it is related to the movement of water droplets and ice particles in the clouds. However, these electric fields don't last forever. When the difference between the positive and negative charges becomes very large, the voltage discharges toward the ground. This discharge occurs in the form of lightning, which is a bright flash of light accompanied by a loud clap of thunder. Before lightning occurs, the air inside the clouds and around them becomes electrically charged. This means that the air molecules gain an electric charge by either gaining or losing electrons. As a result, the air becomes ionized, forming a channel of electrically charged particles known as a lightning channel. This channel allows the electrical charges in the clouds to flow toward the ground. The flow of charges through the lightning channel generates immense heat, causing the air molecules to rapidly expand. This rapid expansion produces a shock wave that we perceive as thunder. Now let's talk about the types of lightning. There are three main types of lightning: cloud to ground, cloud to cloud, and intra-cloud. Each type is unique and has distinct characteristics. Cloud to ground lightning is the most common and familiar type of lightning. It occurs when the negatively charged bottom of a cloud discharges electricity to the positively charged ground. The path of the lightning bolt is called a step leader. It travels in a series of steps, gradually connecting the cloud to the ground. The step leader is followed by a positive streamer from the ground, which connects to the descending step leader and completes the circuit. Once the circuit is complete, a surge of current flows from the ground to the cloud, causing the bright flash of light and clap of thunder. Cloud-to-cloud lightning occurs between two separate clouds. When the electric charges into nearby clouds become significantly different, lightning can occur between them. This type of lightning is less common than cloud-to-ground lightning and is often associated with thunderstorms. Intra-cloud lightning, also known as bolt from the blue, occurs within a single cloud. It is commonly observed during thunderstorms and is caused by the discharge of electricity between regions of opposite charge within the same cloud. Intra-cloud lightning is the most common type of lightning and accounts for approximately 75% of all lightning strikes. It often occurs when updrafts and downdrafts within a cloud cause the separation of charges. Now let's see how lightning strikes. For cloud-to-ground lightning to occur, several conditions must be met. Firstly, a strong electric field must exist between the cloud and the ground. This electric field is generated by the separation of charges within the cloud. Secondly, the electric field strength must be high enough to overcome the insulating properties of the air. Normally, air is a good insulator, preventing the flow of electricity. However, under strong electric fields, the air molecules become ionized, forming a conductive path for the electricity to flow. Thirdly, a conductive path must exist between the cloud and the ground. When the electric field strength is sufficient to ionize the air, a conductive channel called a lightning channel is formed. This channel allows the electrical charges to flow from the cloud to the ground. Once these conditions are met, the lightning strike occurs. The negatively charged region of the cloud discharges electricity to the positively charged ground through a channel of ionized air. The flow of electricity through the lightning channel generates intense heat, causing the air molecules to rapidly expand and produce a bright flash of light and a loud clap of thunder. Now we will learn about thunder, the sound of lightning. As mentioned earlier, lightning occurs due to the discharge of electricity between clouds and the ground. When the electricity flows through the lightning channel, it generates immense heat, causing the air molecules to rapidly expand. This rapid expansion creates a shock wave that travels through the air at the speed of sound. The shock wave reaches our ears as a loud clap of thunder. The delay between the flash of lightning and the sound of thunder is due to the difference in the speed of light and the speed of sound. Light travels at approximately 300,000 kilometers per second, while the speed of sound is much slower at around 343 meters per second. Therefore, when we observe a lightning strike, the light reaches our eyes almost instantly, while the sound of thunder takes some time to reach us. The distance between the observer and the lightning strike can be estimated by measuring the time delay between the flash and the thunder. Each clap of thunder takes approximately 5 seconds to reach our ears after the lightning strike. By counting the number of seconds between the flash and the first clap, we can determine the distance in kilometers. Let's explore some fun facts about lightning. Every second, approximately 100 lightning strikes occur worldwide. These flashes of light illuminate the sky in various shapes and forms, captivating our attention. Lightning is one of the most dangerous natural phenomena on Earth. It is responsible for numerous fatalities and injuries each year. The risk of lightning strikes is particularly high in areas such as open fields, tall trees, or metal structures. During thunderstorms, it is important to take precautions and seek shelter indoors or in a vehicle. In the United States, Florida experiences the highest number of lightning strikes to its location in a thunderstorm-prone region. Pakistan also experiences a significant number of lightning strikes, particularly in coastal and northern areas. These regions are characterized by high humidity and frequent thunderstorms, creating conditions favorable for lightning formation. Now let's discuss some safety tips related to lightning. During a thunderstorm, it is crucial to prioritize safety and take necessary precautions. If caught outdoors, avoid standing in open fields, as these areas are more prone to lightning strikes. Seek shelter indoors or in a covered structure to protect yourself from lightning. Additionally, if there are no nearby buildings or shelters, crouch down low to minimize your contact with the ground. However, do not lie down as this increases the risk of injury. If caught near tall trees, immediately move away from the tree and avoid seeking shelter beneath it. Tall trees are more likely to be struck by lightning, and standing near them increases your risk of being injured. Furthermore, if driving during a thunderstorm, pull over to a safe location and remain inside the vehicle until the storm passes. A car provides a relatively safe shelter as the metal frame conducts electricity, allowing lightning to pass through it without harming those inside. It is also advisable to limit the use of mobile or electrical devices during lightning, as they can attract lightning strikes. Instead, focus on seeking shelter and staying away from windows to ensure your safety. So that was how lightning happens. Some amazing facts and safety tips. The power of nature is truly amazing, and we should respect it. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. Also check out our other videos that appear on your screen right now. Thanks for watching. We will see you next time.